All right, our second type of severe weather is looking at tornadoes and what tornadoes really are all about. All right, once again, you got a video to watch on giving you that 101. Let's jump into the details of this. Definition of a tornado. Violent windstorm takes the form of a rotating column of air called a vortex. Right? And the vortex then will extend downward from a cumulonimbus cloud. So we're talking about thunderstorm type clouds. Right? And often thunderstorms are accompanied by them, but they don't have to be. It's the cloud that allows this to take place. Right? Now, the vortex itself is what the tornado is. And they come in multiple different forms. You can have a single vortex, and so you have one spinning column that reaches down into the ground, right? And sometimes you have what are called multiple vortices in the main funnel. So often when we look at something as they get wider and wider and wider, right, from our perspective, it just looks like one tornado. You might actually have multiple smaller vortices or smaller tornadoes inside of this, and then they're all working together to make it look like a really gigantic one, right? So when I talk about multiple vortices, I'm not talking about this, right? Where you have just multiple single tornadoes coming down, right, like this, but rather we're talking about bigger tornadoes that will have multiple ones inside of them. There's a picture of that coming up in a little bit. But just realize that there are different forms of tornadoes. It's not always just one giant spinning cloud, which means one tornado. Now, this is the part that often confuses people, because when it comes to developing a tornado, the first thing that we have to create is a mesocyclone. And a mesocyclone is not a tornado. Key idea, mesocyclone, not a tornado. It's just once you have a mesocyclone, then tornadoes can form vortexes, or vortexes can form, which is a tornado. Definition of mesocyclone, we have a vertical cylinder of rotating air that develops in the updraft. I think this should say of, not or, as we look at this, of rotating air, developing in the updraft, all right? And the mesocyclones is just that. It's just a cloud that's spinning. That's all it is. And you can see it here, right? Here's giant cumulonimbus cloud, but you can see the curve forming, which is the mesocyclone. How does this actually happen, right? This leads to tornadoes. But what you have to have first is you have to have these rolling winds where you have slower winds closer to the ground, usually because of friction, trees, just the land itself. And then higher up, you have faster winds. And because you have this combination, this slow, fast, it starts creating these cycles, and it just starts rolling along. You got pictures of like a log rolling around on the ground. And that's the wind, what the wind is doing, just making that motion, and then the faster speed keeps it going, and then it cycles and it cycles and it cycles. Eventually, as that air moves, you get the updrafts caused by the cold front and the warm front running into each other, and that creates the updraft. So it takes this spinning air that's going this way, pushes it up, and then it flips it. And once it flips it, now it's inside of this cloud, and it creates a mesocyclone, and it spins all the way up the cloud. This spinning mesocyclone is now creating this extremely fast and powerful updraft that is being pushed up high into the cloud, right? And then as the downdraft comes, some of that air is going to continue to feed it, which will cause a vortex to form. And so here's your tornado, here is your mesocyclone. Tornado happens way down here, bottom of the cloud to here. Here's your mesocyclone, all the way up in the atmosphere, right? Much, much larger than any tornado we've ever seen. But this isn't going to cause any damage. The tornado is what's going to cause damage, right? But that's what's happening. And eventually, right, if a vortex forms, it's going to push down, and it's going to create this single downdraft with this updraft all within inside this, which is what a tornado actually is. So a little bit different. You need a mesocyclone to be formed, and then once it's formed, then the conditions are set for a tornado to form. Right? But the mesocyclone is not what just drops down and becomes a tornado. Right? So the mesocyclone is not the tornado, it just is what you need. Right? When it comes to tornadoes, right, we have a lot of them. 770 per year. Right? Typically we see them in spring to early summer. You have Tornado Alley, which is kind of this part of our country, is what it's looking at. Though it is, according to climate change, it's shifting this way, according to climate scientists. So Oklahoma, Kansas, Missouri, Arkansas, Tennessee, Alabama, Mississippi, right? Big tornado alley. They get tornadoes every year, right? No question asked, right? Where you move further up into where we live, you look at this, we get thunderstorms. So because we get thunderstorms, if the conditions are right, if you can get that mesocyclone forming, we can also get tornadoes. And so we will get occasional tornadoes, but definitely not as consistent as you get them down in this part of our country. Right? So here's kind of the general picture of tornadoes. This is the last 60 or so years of tornadoes, and you can just see just how many are kind of here and here, you know, and even in this part, right? It's not that we're not getting them here, but the big red ones, those are the big ones, the stronger ones that are happening, that are causing lots and lots of damage. How do we start to measure tornadoes or understand tornadoes? A lot of it has to do with the intensity. Here's a picture of a tornado, right? Center of tornado. Here we have, three vortices. That's the right word, right? So three individual smaller tornadoes that are working together to create a much, much larger tornado. That's what we call a multiple vortice tornado. But what's happening inside of there is there's a pressure change. And when we get a pressure change, right, it's lower just 10%. But now that you have this low pressure center that comes with the thunderstorm and it lowers even more, remember, high pressure wants to go to low pressure. And so then it causes this suction to come down. And that when that pressure drops, that's when the air is going to drop and it's going to create these vortices that are then going to be tornadoes and start causing the damage due to what's going on, right? And the worst ones are going to go, the worst recorded ones can go up to 300 miles per hour, right? So in terms of wind speed, tornadoes are much, much faster than hurricanes. Hurricanes are much larger in size, and so they last longer, but tornadoes, the air moves much, much faster as a whole, right? Finding tornadoes can be a challenge because we can see the storm systems. Sometimes you can start to see some motion up high from a mesocyclone, but you can't see down low where the tornadoes are actually going to form, which is why you need people to be storm chasers to go looking for those things. Because of the danger that comes with tornadoes, whether you see Twisters or the old Twister movie, right? They're doing whatever they can to get technology into these things, but in the end, when it comes to talking about different kinds of tornadoes, it's not about a direct measurement of wind speed, because it's very hard to just step up to a tornado and say, hey, let me measure you quickly without it killing you. So instead they focus on the damage that comes. And based on that, we have what's called the Fujita scale. So we have F0, those are going to be the gentler ones, 40 to 70 mile per hour winds. And then as you increase, you go up about 30 miles per hour each time until you get to an F5, which is 318 has been recorded, right? Huge amounts of damage, right? We're talking about everything being blown down compared to just branches breaking and roof tiles coming off. Right, so this is these are the pictures that I found, right? So this is an F0, F1, F2, F3, and you might say this one doesn't look as bad, but this building is made out of brick compared to these ones made out of wood. Here you got an F4, and here is an example of an F5. Like, I mean, nothing has been left standing, right? How that truck stayed there, I have no idea, right? Just huge, huge amounts of destruction. Because tornadoes are a real thing, we got to think about safety. There's places in Norman, Oklahoma Storm Prediction Center. They do what they can to forecast. They watch the severe weather of the thunderstorms, and they're working hard to be able to predict them. From there, you can get tornado watches. A watch means there's the possibility of a storm. A warning means that a tornado has been sighted. Maybe it hasn't reached the ground yet, but you can see the spinning up in the lower part of the clouds. Or they're able to see something through radar with the advances in technology. If you love tornadoes, watch the storm chasing video. Should do a sign. Special tornadoes I should say. Water spouts, those are tornadoes that form over water. Much rarer, but they do happen. And then of course they're gonna carry water with them as they're moving. These other two, dust devils, fire whirls, they look like tornadoes, but they are not actually tornadoes. They don't form that same way. They don't have that rolling air that gets updrafted and turns into a mesocyclone, right? Still, dust devils have to deal with the unequal heating of the earth, and they cause these little twirls that can reach up, right? Not super huge at causing massive destruction, but can definitely be an annoyance as you work with that. Fire whirls often happen when tornadoes go through or there's a fire, and now you just have the right conditions to cause a little bit of a cycle to go, and then the fire just gets picked up in the air, and you create, it looks like a fire tornado, but it's really just spinning air really fast within our atmosphere. That's tornadoes.